Hello, welcome. Another episode on Coordinate Geometry 1, episode number 4. In this episode, we want to take an application of the previous formula, that is the length of a line or the distance between two lines. How we can apply that to identify a specific type of triangle. So you can see the point A, B, and C are the point 3, 5, 7, 2, and 3 minus 1, respectively, meaning A, B, C. What type of triangle is triangle ABC? Meaning these are the vertices of that triangle. So how do we do that? Let's say we have a visual of the point A, 3, 5, B, 7, 2, C, 3 minus 1. This is the triangle. You want to know the type of triangle that this will be. First of all, we need to know that a triangle has some properties. If all the sides are equal, equilateral. Two of the sides being equal, isosceles. None being equal, scalene. If you happen to have a right angle, we indicate right angle triangle. So I need to know how long is this line. That can determine. That is where the distance formula comes into play. I find the magnitude of all the sides and compare. So knowing the point, I am picking the first one here. Okay, let me indicate P, Q, which we don't have, just to drum home the formula. X2 minus X1 all squared, Y2, Y1 all squared. That is the formula we derive from the second episode. So let's begin with the first one, which will be the length of AB. Where are we going to find the X1, the X2? This is the A, the beginning. This is your X1, Y1. Remember the coordinate? X comes first before the Y, right? So this is also going to be X2, Y2, X1, X2, Y1, Y2. Alright, so how do we introduce that into the formula? X2 is what? 7. So 7 minus X1 going to be 3 all squared, Y2 which is going to be 2 minus Y1 which in this case will be 5. All this squared. So let's see what the computation will be. In that bracket will be 4. 7 minus 3 will be 4. So 4 squared. This is going to be 2 minus 5 will be negative 3. So let's put a negative 3 all squared. So this will give us 16 plus 9. Don't forget, negative 3 times negative 3 give you a positive 9. So this will give us the root of 25 equals to 5 units. It means the distance between A and B will be 5, regardless of the unit. Then let's pick AC, right? Following the same formula, this is our first point A going to C. So X1, X2, Y2. This is the first point, second point. So from here, you come here. So I'll be beginning from here. That will be 3 minus 3, right? All squared. Then I begin from here. Minus 1 minus 5. All squared. Fast forward. This will be 3 minus 3. 0. Let me just bring it there. Minus 1 minus 5 will give you minus 6 all squared. So negative 6 times negative 6 will give us a positive 36. This will be 0. So I'll be having root 36 equals to 6 units. 36 is a perfect square. So we have that. So we now know the unit here. We are left with the unit between B and C. So to find BC, we can have the length of BC equals to the root of, so this is going to be our first x, first y, second x, second y. You can see I am beginning from B to C, so I have to relabel the dimension. So here I begin from 3 minus 7 plus, where are we going? Okay, negative 1 minus 2 all squared, right? y2, y1. And that will give you minus 4 all squared plus minus 3 all squared. This is negative 1 plus negative 2. It will increase in number. Alright, so this will become negative 4 times negative 4. That will give you positive 16. Negative 3 times negative 3 give you 9. And that will give you the root of 25 equals to 5 units. So if this is going to be 5, 5, and 6, what do you think will be the type of this triangle? So we can say that since the magnitude of AB equals to that of BC, and they are all equals to 5 units, right? Or 5, let's say 5. We can say that triangle, okay, ABC is going to be an isosceles triangle. Why? Because two of the sides are equal. So if two sides are equal, then we can say that that will become an isosceles. If all the three sides are equal, equilateral. None being equal, scalene. I guess the concept of the application of the length of a line in finding the type of a triangle is understood by you. Like, share, and comment. Bye-bye.